Good morning, students. This is Professor Kavita Kamerikar from Sagar Institute of Science and Technology, Bhopal. Today, our topic of discussion is the first topic of unit number 3, that is the introduction of transducer and classification of transducers. This is the lecture plan 22 of the subject EMI. So, let's start with the topic classification of transducers. Before that, we will discuss what is transducer. There is generally a confusion between the transducer and sensor. So, for this we will discuss the block diagram of a simple measuring system that contains three basic elements. First is sensor, second is signal conditioning unit, and the third is data representing device. As you can see from the diagram, the sensor and signal conditioning unit together can be called as the transducer. So we can define the sensor as a device that is used to detect change in any physical quantity like temperature, speed, flow, level, pressure, etc. So any change in the input quantity will be detected by a sensor and reflected as change in the output quantity. So sensor is a device that responds to physical change. Both the input and output quantities of a sensor are physical, it means non-electrical in nature. So in this diagram we can see that the physical quantity to be sensed is applied to the sensor and the output is sensor is going to the signal conditioning unit. And this is the non-electrical quantity. The input of the sensor is a non-electrical and the output of sensor is also non-electrical. And the output of the transducer is electrical. So transducer is a device that converts non-electrical quantity into electrical quantity. In terms of electrical and electronics instrumentation, we can say this definition. We can define this type of transducer. So transducer is a device broadly that converts one form of energy into another by the principle of transduction. Usually, a signal in one form of energy is converted to a signal in another form by a transducer. In terms of the electrical instrumentation, a transducer is a device that converts a non-electrical quantity into an electrical quantity. So, it is the basic difference between the transducer and sensor. So, we can say that all the transducers are sensor, but all the sensors are not transducer because they are not converting any physical quantity into electrical quantity. So it is the basic difference between the sensors and transducer. Sensors is sensing any physical quantity and transducer convert non-electrical quantity into electrical quantity. So this is the difference between the sensor and transducer. So let's start with the classification of transducers. Transducers may be classified according to their application, method of energy conversion, nature of the output signal, and so on. Broadly, it can be classified into 5 categories. First category is on the basis of transduction principle used. In this, it can be a capacitive, inductive, resistive broadly. There are many more categories also in this principle of transduction, but broadly we can classify into 3 major categories, that is a capacitive transduction, inductive transduction, and resistive transduction. Next classification is active and passive. Third is primary and secondary. Fourth one is analog and digital, and the fifth is transducers and inverse transducers. We will discuss it one by one in detail. First, we will discuss active and passive transducers. As we can say that active transducers are the transducer that do not need any external source of power for their operation. Therefore, they are also called as self-generating type transducers. The active transducers are self-generating devices which operate under the energy conversion principle. As the output of active transistor, we get an equivalent electrical output signal, for example temperature or strain, to electric potential without any external source of energy being used. So in the active transducer, it is self-generating type of transducer that doesn't require any external source of supply for its working. The examples of active transducers are photovoltaic, thermoelectric, piezoelectric, electromagnetic. For example, piezoelectric transducer is a type of active transducer that requires only an external force to change in voltage that generated across the surface, and this change is measured by its corresponding value of sound or vibration. What is the principle of piezoelectric? When an external force is applied, there will be change in the voltage generated across the surface. So there is no need of the external power to create the change in voltage. So it is a type of active transducers. Next is passive transducers. These transducers need external source of power for their operation. So they are not self-generating type of transducers. A DC power supply or an audio frequency generator is used as an external power source. These transducers produce the output signal in the form of variation in electrical parameter like resistance, capacitance और inductance. जैसा कि हमने एक्टिव में देखा था, यहाँ पर हमें टेम्परेचर स्ट्रेन इस फॉर्म में चेंज होकर मिल रहा था, इस फॉर्म में हमें आउटपुट मिल रहा था. बट इन केस ऑफ पैसिव ट्रांजिस्टर we will get the output signal in the form of electrical parameters like resistance, capacitance or inductance. The examples of passive transducers are thermistor, strain gauge, LVDT. In the thermistor, we will get the change in the resistance. In the strain gauge, also change in the resistance. In the LVDT, change in the inductance will cause the change in the voltage. LVDT is linear variable differential ट्रांसड्यूसर. इसको हम बाद में डिटेल में भी डिस्कस करेंगे. अभी के लिए पैसिव ट्रांसड्यूसर के एग्जांपल्स में इसको देखेंगे. द एग्जांपल्स आर थर्मिस्टर, स्ट्रेन गॉज एंड एलवीडीटी. दीज आर द मेन एग्जांपल्स. वी कैन क्लासिफाई पैसिव ट्रांसड्यूसर लाइक in 3 broad category: variable resistance, optoelectronic and variable reactance. In the variable resistance, it can be classified as photoconductor, strain gauge and thermistor. इन तीनों में रेजिस्टेंस वेरी होगा और इस जो वेरिएशन को ही हम इलेक्ट्रिकल क्वांटिटी में कन्वर्ट करेंगे. देन ऑप्टोइलेक्ट्रॉनिक के 2 टाइप्स क्या है? फोटो एमिसिव एंड फोटो जंक्शंस. एंड वेरिएबल रिएक्टेंस आर 2 टाइप्स: इंडक्टिव एंड कैपेसिटेंस. इन कैपेसिटिव वेरिएबल एरिया, वेरिएबल सेपरेशन, वेरिएबल परमिटिविटी. तो कैपेसिटर किस पर डिपेंड करता है? एरिया पर, सेपरेशन पर और परमिटिविटी पर. तो इन तीनों को वेरी करके हम कैपेसिटेंस को वेरी कर सकते हैं. सो चेंज इन द कैपेसिटेंस विल कॉज द चेंज इन द आउटपुट. एंड द इंडक्टिव ट्रांसड्यूसर कैन बी डिफाइंड एज वेरिएबल रिलक्टेंस, वेरिएबल परमेबिलिटी, एलवीडीटी एंड एडी करंट. सो इन 4 ऑफ दिस एलवीडीटी इज मोस्ट इम्पॉर्टेंट. सो अभी हमें इसको कल ब्रीफ में डिस्कस करना है. वी आर डिस्कसिंग हियर ओनली फॉर इंट्रोडक्शन. वी विल डिस्कस इट इन डिटेल आफ्टरवर्ड्स. Next classification is primary and secondary transducers. Some transducers contain the mechanical as well as electrical device. The mechanical device converts the physical quantity to be measured into a mechanical signal. Such mechanical devices are called as the primary transducer because they deal with the physical quantity to be measured. यहाँ पर 2 तरीके से एक ही सर्किट में हम 2 ट्रांसड्यूसर यूज़ करेंगे. एक को हम बोलेंगे प्राइमरी, दूसरे को बोलेंगे सेकेंडरी. सो प्राइमरी ट्रांसड्यूसर विल कन्वर्ट द फिजिकल क्वांटिटी इनटू अ नॉन इलेक्ट्रिकल क्वांटिटी एंड दे डील विद द फिजिकल क्वांटिटी टू बी मेजर्ड. इसको क्या बोलेंगे हम? प्राइमरी ट्रांसड्यूसर. एंड नाउ द सेकेंडरी ट्रांसड्यूसर विल कन्वर्ट दिस नॉन इलेक्ट्रिकल क्वांटिटी into an electrical quantity. So there are 2 types of transducer can be used in one circuit, like primary and secondary transducer. So there is an example of primary and secondary transducer in this diagram. Here we use Bourdon tube as a primary transducer and LVDT as a secondary transducer. Bourdon tube has fixed end and free end. This is a mechanical device that converts the pressure and it sends the pressure and convert it into displacement. This displacement is taken out by the pulley and to the core. It is connected to the soft iron core, as you can see from the diagram. Bourdon tube क्या करेगा? Pressure को sense करेगा, and due to this pressure there will be displacement. So there will be pressure is converted into displacement. Physical quantity is converted into mechanical quantity. Now the soft iron core is connected with the pulley. The movement of the soft iron core due to the displacement will be happen in the upward or downward direction. Now this core is connected with the primary winding of the LVDT. Due to the displacement of the core or the movement of the core, there will be change in the flux, and this change in the flux will be obtained at the secondary winding. So there will be change in the voltage. Here, as you can see, the primary transducer converts pressure into displacement, and the LVDT, that is a secondary transducer, that converts displacement into voltage. So here voltage is proportional to displacement and displacement is proportional to the pressure. So in this diagram we are using two types of transducer, primary transducer as a Bourdon tube and secondary transducer as a LVDT. So this is the basic concept of primary and secondary transducer, where we have to convert first is into non-electrical and then again in electrical quantity. Next classification is according to the transduction principle used. There are three basic transduction principles, that is resistive, capacitive and inductive. After that, electromagnetic, piezoelectric, photovoltaic and photoconductive transduction is also there. So we will discuss in brief here, because there are number of examples of all this transaction that we have to discuss later in this unit. So starting with the resistive transaction. In resistive transaction, the resistance changes due to the change in some physical phenomena. Like resistance का formula क्या होता है? R equals to rho L upon A. If we are changing the cross sectional area of conductor, that is A, or we are changing the length of the conductor, then the resistance will change. And if the resistance is changed, then the output voltage will also change. So it is the principle of resistive transaction. The example of resistive transaction is strain gauge. The strain gauge works on the principle of change in the resistance. Next is capacitive transaction. Here the measurand is converted into a change in capacitance, and change in capacitance occurred either by changing the distance between the two plates or by changing the dielectric. The capacitance depend upon the area and separation and the dielectric. So by changing any of this quantity we can change the capacitance, and the measurand will be converted into a change in the capacitance. Next is inductive transaction. In inductive transaction, the measurand is converted into a change in the self-inductance of a single coil. This is accomplished by displacing the coil's core, which is linked or attached to a mechanical sensing element, as shown in the figure. यहाँ पर क्या होगा? कोर का डिस्प्लेसमेंट होगा. Due to this, there will be the change in the self-inductance of the coil, and there will be change in the output voltage. So the example of inductive transaction is LVDT, linear variable differential transducer. Next type of transaction is electromagnetic transaction. In electromagnetic transaction, the measurand is converted to voltage induced in conductor by change in the magnetic flux in the absence of excitation. The electromagnetic transducers are self-generating type transducer or active transducer because there is no need of external power to operate it. The motion between a piece of magnet and an electromagnetic is responsible for the change in flux. So here we can see that the major end is converted to the change in the voltage, that is due to the change in the magnetic flux. So it is the principle of electromagnetic transaction. It works on the principle of Faraday's law of induction. Next is piezoelectric transaction. In piezoelectric transaction, the major end is converted into a change in electrostatic charge or voltage that is generated by crystal when it is mechanically stressed. जैसे कि piezoelectric की क्या प्रॉपर्टी होती है कि जब यहाँ पे हम क्रिस्टल को यहाँ पे हम जब प्रेशर क्रिएट करेंगे तो वो किस फॉर्म में कन्वर्ट होगा, इट विल बी कन्वर्ट इनटू सम चेंज इन द वोल्टेज. सो इट इज़ द प्रिंसिपल ऑफ पीजोइलेक्ट्रिक ट्रांजैक्शन. अगर कंप्रेशन करेंगे तो भी चेंज होगा, जैसे कि हम डायग्राम में देख सकते हैं. इफ़ वी आर कंप्रेसिंग द क्रिस्टल देन ऑल्सो देयर विल बी चेंज इन द चार्ज और द चेंज इन द वोल्टेज. सो द मेजर एंड इज कन्वर्टेड इनटू अ चेंज इन द voltage. Like bending also, if you are bending here then also there will be a change in the voltage. So in piezoelectric transaction we are applying a pressure that is converted into the change in voltage. It is the principle of piezoelectric transaction. Next is photovoltaic transaction. In the photovoltaic transaction, the major end is converted to voltage generated when the junction between the dissimilar material is illuminated. जैसे कि हम डायग्राम में देख सकते हैं, जब यहाँ पे लाइट आएगी, यहाँ पे लाइट, when the light will be there, when the illumination will be there, then there will be voltage generation occurs. So the major end is converted into a voltage due to the illumination. अगर लाइट वेरी होगी तो वोल्टेज भी वेरी होगा. So there will be the change in the voltage according to the change in the intensity of light. So it is called as the photovoltaic transaction. Next is photoconductive transaction. In photoconductive transaction, the major end is converted to change in resistance of a semiconductor material by the change in the light incident on the material. अब जैसे वहाँ पर हमने वोल्टेज के लिए बात की थी, वैसे यहाँ पर क्या होगा, हियर विल बी द चेंज इन रेजिस्टेंस ड्यू टू द चेंज इन द लाइट इंटेंसिटी. तो यहाँ पर इसके रेजिस्टेंस में चेंज होगा, दैट विल बी द ड्यू टू द चेंज इन द इंटेंसिटी ऑफ लाइट. सो दिस इज कॉल्ड एज द फोटोकंडक्टिव ट्रांजैक्शन. So these are the basic types of transaction principle. Next classification is analog and digital transducer. The analog transducer convert the input quantity into an analog output which is a continuous function of time. Like strain gauge, LVDT, thermocouple, thermistor, these all are the example of analog transducer. क्योंकि इसमें हमें किस फॉर्म में आउटपुट मिल रहा है, इन द फॉर्म ऑफ द वोल्टेज. सो इट इज़ अ टाइप ऑफ एनालॉग ट्रांसड्यूसर, जिसमें कि हमको कंटिन्यूस वोल्टेज मिलेगा और द आउटपुट विच इज़ अ कंटिन्यूस फंक्शन ऑफ टाइम. सो दिस इज द एग्जाम्पल्स ऑफ एनालॉग ट्रांसड्यूसर. द अदर classification is digital transducer. These transducer convert the input quantity into an electrical output which is in the form of pulses and its output is represented by 0 or 1. तो यहाँ पर जो भी इनपुट क्वांटिटी होगी उसको हम इलेक्ट्रिकल आउटपुट में कन्वर्ट करेंगे और उस आउटपुट को हम पल्स के फॉर्म में कन्वर्ट कर सकते हैं. और पल्स के फॉर्म में क्या रहेगा, या तो उसकी वैल्यू 0 होगी या फिर 1 होगी. सो दिस टाइप ऑफ ट्रांसड्यूसर इज कॉल्ड एज डिजिटल ट्रांसड्यूसर. इसका एग्जाम्पल है ऑप्टिकल इनकोडर. नेक्स्ट क्लासिफिकेशन एंड द लास्ट क्लासिफिकेशन इज ट्रांसड्यूसर एंड इनवर्स ट्रांसड्यूसर. ट्रांसड्यूसर क्या करता है, ट्रांसड्यूसर कन्वर्ट नॉन इलेक्ट्रिकल क्वांटिटी इनटू इलेक्ट्रिकल क्वांटिटी. तो इनवर्स ट्रांसड्यूसर क्या 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 रहेगा, इट विल डू द अपोजिट ऑफ ट्रांसड्यूसर. इट विल कन्वर्ट इलेक्ट्रिकल क्वांटिटी इनटू अ नॉन इलेक्ट्रिकल क्वांटिटी. इसका जो बेसिक एग्जांपल है हम इसको समझ सकते हैं पीजो इलेक्ट्रिक क्रिस्टल से. A piezoelectric crystal acts as an inverse transducer because when a voltage is applied across its surface, it changes its dimension that causes a mechanical displacement. जब पीजो इलेक्ट्रिक क्रिस्टल पे हम वोल्टेज अप्लाई करेंगे, इट विल कॉज द चेंज इट्स डायमेंशन, और इसमें एक स्ट्रेस क्रिएट होगा जो जिसके कारण इसके डायमेंशन में चेंज होगा. तो यहाँ पे इलेक्ट्रिकल क्वांटिटी किस में कन्वर्ट हो गई? मैकेनिकल क्वांटिटी में. सो this is a type of inverse transducer in which electrical quantity is converted into a non-electrical quantity. So it is a type of inverse transducer. So that's all about the classification of transducer. In this lecture we have discussed introduction of transducer, difference between the sensor and transducer, then classification of transducer on the basis of the transaction principle used, active, passive, primary and secondary, analog and digital, transducer and inverse transducer. Thank you.